Hello and welcome. My name is Niki Pfeifer, and I'm going to introduce my poster towards an experimental philosophy of argumentation to you. The goal of this work is to expand the domain of experimental philosophy to argumentation in order to describe and explain what makes a strong argument, to understand how argumentation actually proceeds and should proceed in a rational way, and to build bridges among relevant research disciplines and traditions, including philosophy, psychology, and AI, and so on. Let's consider an example: intuitions about argument strength. People or laymen and experts have some intuition about what makes a strong argument. That is, they can easily make sense of qualifiers like this is a strong argument, this argument is weaker than the other one, or holding a degree of belief or a high degree of belief in this conclusion. Thus, an XPHI argumentation should account for classifying and comparing arguments according to their strength and how degrees of belief in conclusions are and how they should be formulated. Now some basic concepts that I use. By argument, I mean the order triple consisting of the premises or the premise set, the conclusion indicator, and the conclusion. And I don't mean by argument a premise. Coherence-based probability logic, or CPL, combines logic, that is rule-based qualitative reasoning, with probability, quantitative reasoning, and it is based on coherence. Coherence was originated by Bruno De Finetti and later generalized to conditional probability, and it involves the following features. For example, probability is subjective, that is, it is interpreted by degrees of belief. It can be interpreted in terms of proper scoring rules or in the avoidance of Dutch books. It does not require a complete algebra. Coherence defines conditional probability as primitive and not, as in most approaches, by the fractions of the joints over the marginal, where you need to presuppose that the conditioning event has a positive probability. In the coherence approach, however, zero probability antecedents are defined and properly managed, while this fraction definition here remains undefined if the probability of A is zero because you have a fraction over zero. Coherence allows for imprecision, that is probability intervals, non-monotonicity, and many other philosophical and psychologically appealing features. CPL is about transmitting the uncertainty from the premises to the conclusion in a coherent way. Now I come to 5 postulates that I have for an XPHI of argumentation. 1, the research question should be philosophical. That is, what is argument strength, as an example. 2, key concepts should be empirically validated, for example, by controlled psychological experiments. 3, key concepts should be made explicit by formalization. 4, truth functional binary logic is inappropriate as a rationality framework for argumentation. Rather, I suggest coherence-based probability logic. 5, the focus in argumentation should be on the conclusion or on argument strength, but not on some abstract properties like validity. The justification of the first 2 postulates is trivial as they are just analytically true. They follow from the very concept of experimental philosophy. Let's have a look at the justification of postulate 3, the formalization. Formalization can make ideas clear. Linguistic ambiguities and unclarities can be avoided. Informal mathematical derivations are hard or even unintelligible in ordinary language. Formalization allows really to calculate in a broad sense. Formalization allows to make subtle differences explicit, which would get lost in ordinary language. For instance, consider the following argument. Consider if A then B, will not A if not B. This argument is ambiguous with respect to the interpretation. For example, it is ambiguous what belongs to the premise set and what belongs to the conclusion. You could interpret this argument as a kind of a modus tollens. If A then B, not B, therefore not A. So the not A here would be the conclusion. Or you could interpret it as a contraposition. If A then B, therefore if not B, then not A. Now, if we interpret these 2 argument forms probabilistically in coherence-based probability logic, we get the probabilistic modus tollens here and the probabilistic contraposition there. The probabilistic contraposition is probabilistically non-informative. This means that whatever value x you have here, you always get 0, 1 as the tightest possible coherent bounds on the conclusion. In other words, you cannot infer anything about the conclusion here. For the probabilistic modus tollens, however, you can infer at least the lower bound, which is given by the lower bound on the conclusion, which is given by these formulas here. These are the probability propagation rules in modus tollens. So depending on how you interpret the argument, how you formalize the argument, it is important, the interpretation. Otherwise, these subtle differences between these two interpretations get lost and you don't know what you're talking about if you just consider the words here. Now let's go to the justification of postulate 4. In coherence-based probability logic, the conclusions are retractable. It's non-monotonic. It allows for expressing uncertainty in terms of degrees of belief, and conditionals are properly formalized by conditional probabilities, which is strongly confirmed by experimental data. Since logic is monotonic, that means you cannot retract conclusions in the light of new evidence. Bivalent, this means you either have the value true or false, but you cannot express degrees of belief. And because logic is unable to formalize conditionals properly, you have all these paradoxes of the material conditional is not really conditional, and so on. I propose coherence-based probability logic, which avoids all these problems. And we have we collected a lot of experimental evidence, which also justifies this choice. Let's go to justification of postulate 5. People argue for something, that is the conclusion, but are not interested in abstract formal properties like logical validity. Thus, the focus of an XPHI of argumentation should be on the conclusion or on the overall strength of the argument. I proposed a measure for argument strength, a formal one, which in a nutshell means that an argument is strong if and only if the conclusion interval, the tightest possible coherent conclusion interval, is rather narrow, so you get a tight interval, which is close to 1. So satisfying these two features, the narrowness and the closeness to 1, yields a nice measure of argument strength, where you obtain, for example, 1 if the conclusion probability is precisely 1, but you obtain 0, for example, if the conclusion probability is precisely 0, or if the conclusion probability is anywhere between 0 and 1, if it is a probabilistically non-informative argument, like in the contraposition we just discussed. And now let's go to build some bridges to other disciplines. We showed that this measure of argument strength that I just explained was confirmed experimentally and offers a new solution to the Ellsberg paradox. This is an example where XPHI bridges argumentation theory, that is the question of how to formalize argument strength, and decision theory, in the sense that we provided a new solution to the Ellsberg paradox by applying this measure. We also have a paper on building a bridge to artificial intelligence, where we have experimental philosophical work on basic rationality principles of argumentative attacks. So here you can see the literature I used for this presentation. And I thank you very much for your attention.